everyone. Thank you for joining us here. Aragani-san, nice to see you again.
Nice again.
We don't get a chance to chat much, so this is going to be a great opportunity for us to have a little coffee discussion, me, you, and the folks in the room, as well as the folks online. So today is going to be a discussion that we want to talk about IOWN and IOWN use cases and proof of concepts. But first, perhaps what we should start with is a definition of IOWN, which you've heard already, and then a definition of what is a very important collaborative effort called the IOWN Global Forum. So the IOWN concept, Innovative Optical Wireless Network, is something that was first introduced in 2019. And the concept is around converting our infrastructure from the network to the data center to the devices to ultimately sensors based on photonics.
Yes.
Now, that is an important step towards, as you heard Rika talk about, a more sustainable future, especially with AI now coming on top of everything we already were planning for, which is a very significant increase in data and processing. So it's a concept that we've invested billions of dollars in, and we're now starting to see some great use cases, so I'm going to get to that. But also I wanted to introduce to those of you who may not know the consortium called the IOWN Global Forum. It's a very, very important part of our strategy because we know that we can't do this on our own, and we need to have very trusted and committed partners to do that. The IOWN Global Forum is made up of over 130 industry-leading partners, and it goes across the gamut from hardware providers, network providers, Ericsson, Nokia, NVIDIA, Intel. The original founders were Intel, Sony, and NTT. But it's a fantastic consortium because we're like-minded, moving towards the idea of a more sustainable infrastructure, but also secure, fast, with low latency. So I'm happy then to dive into our discussion.
Yeah.
And let's start first, Aragani-san, explaining perhaps how does the IOWN Global Forum and the IOWN Development Office consider use cases and proof of concepts? What's the process that you go through?
Okay, thank you, Vito.
Sure.
Okay, I'm the kind of the founding individual with the IOWN Global Forum, so that we discussing with what is the IOWN Global Forum, or how we developed the IOWN Global Forum in the end of the 2019, that where we discuss about, we should discuss not only the technology side, but also the use case side. The user side is important for the improving our business to the developing or enabling the sustainable society. So that in that sense, that IOWN Global Forum, they had in early stages, we have the use case working groups, where we discuss about first about what is the requirement of the use cases or the business cases for the sustainable society. That's the first point. And the second point, for that to fulfill the requirement, what kind of the future or technical future or the business future we'd like to fulfill to enable that. That we call it that the use case reference implementation model. And after that, we should prove the business value, or we should show the business value utilizing the IOWN technologies, as Vito mentioned, the optical technology as well. And so that we make the POC reference document. And based on that, the series of requirements or the definitions that the IOWN Global Forum members starting to design and execute their own POCs. It proves the real business cases.
Right. So it's a great process because you first define through the reference implementation model what are the key requirements, and that sets the foundation then for the working groups to come together to say, if these are the requirements, how do we achieve the benefits? And I've seen some of the reports and that the team produces, and it's a great mix of technical targets or requirements and business outcomes. And so that's a very important approach. Now, I know also that the IOWN Global Forum kind of split not split, but created two buckets, if you will, the cyber-physical and the AI integrated.
Yeah.
Could you maybe describe the difference between those two?
Okay, thank you, Vito. Okay, yes, as Vito mentioned, that at the first stage, that we set the kind of the series of the use cases that we collect a lot of types of the use cases from the IOWN Global Forum members. And also that we'd like to categorize them into the two buckets. Okay. The one is physical, I'm forgetting, cyber-physical. Cyber-physical. That means that realizing the real business of the manufacturers or the industries to utilizing the beyond human capabilities. And another one is the AI integrated communications that emphasizes human powers over the communication powers, utilizing the IOWN capabilities like the real-time communications, even in the far-from, long distance apart of them.
So really, it's almost like those two cases are, one is more physical and one is more digital.
Yeah.
So the physical application, and we're going to talk about mostly, I think, physical versions of this today. But also, there's a case for using IOWN in digital applications like interactive sports or interactive entertainment or gaming, which is all online and digital. So so that's great. So the IOWN Global Forum has really come a long way because as it started first as a very technical focused group, I've seen now over the last 2 years the very strong urgency and need to start defining IOWN as a business value. And the use cases that we're going to talk about really zeroed in on what's the value of an IOWN implemented solution, mostly around the Photonics network. So let's jump into it. So the first one that I wanted to cover was in the category of what you call industry management. And it's really about factory floor. And in this particular use case, it's around a chemical, chemical factory. But it's also useful in petrochemical factories or other process-based manufacturing. So tell me, first of all, what was the business requirement that you were addressing with this use case?
Okay. So since the IOWN Global Forum consists of a lot of types of the industries, and also that I would mention about the members that not only from the technical side, but also that the companies, they would like to utilize IOWN Global Forum technologies for improving their business. Or in other words, they are the user companies. So that they are together with such companies that we can easily collect their real business issues, business problems to be solved. So that they said, please solve these business issues for improving these industries. As Vito mentioned, the first of all, I'd like to mention about the chemical industries. So as you know, that the chemical industry has their own chemical plants in the global wide. So that their issue is that the maintenance of their plant in the global wide. So that one of the very big issues they have is the lack of the human resource. So the specialists, professional of the maintenance, is not enough for dealing with the global-wide plants in anywhere in the global-wide. So that sometimes such specialists has to stay their life in the most of the time in the plane. That moving the one plant to the another plant and another plant every day or every week, every year. So that it is difficult for such industries to find out such professional to keep their resources over the full time of a year. So that they would like to utilize IOWN technologies to the remote maintenance or the remote precise measurement of the predicting when will this equipment will load over something. So that if such kind of the maintenance supporting system will help them, they can ask another person if we can only secure their time only there in the morning or the afternoon due to their health problem or due to in the morning he or she can think about their children or something. In that case, so that they would like to really utilize such a remote maintenance. And also that the maintenance in the chemical plant is very dangerous environment, so that the very high level, 2, 3, 4 level the maintenance field or the explosion or something. So that they are also utilizing the remote, utilizing the drones or remote camera or something. Is very, very important to reduce such accidents of that. There are very emerging issues they would like to solve. Right. And so that they are very interested in the IOWN technologies of the long distance, but the ultra low latency, and as well as the ultra low zeta duration of latency. That because they are in the maintenance, they handle the valves. And sometimes they have to feel the feedbacks of the valve or the strong or the weak or something. And automatically the close the valves. That the system would be explosion. So that the feedback is very important in real time.
The haptic feedback.
Yeah, haptic.
So yeah, this is an example that has always been talked about, using more technology to manage dangerous sites and being able to do predictive maintenance. But the difference here is that with the IOWN capabilities of low latency and low jitter, in case people don't know, that's a technical word for consistent latency, because changes in latency can give it a hiccup, and you don't want the drone having a hiccup because it can turn the valve the wrong way. But really, this is about remote drones and remote robots being centrally controlled with highly skilled people using an IOWN-based network that is able to operate in severe environments. And it changes now the mechanics and the cost of managing these very large plants. And these are large chemical plants all over the world. So, you know, we've talked, one of the things we talk about with IOWN is it's helping us do those things that we've always said we needed to do. Because we need to get to that generation where that robot turning that valve is as near like a human as possible. And for that, you need low latency, high speed, and no jitter. So that's a great example of how, and that's probably an AI drone as well. So let's throw that in there, because we got to throw AI into everything. But that's a good example of how this kind of technology can help solve real business problems. So that's a good example for the manufacturing side. Now let's go to a totally different industry, the finance industry, one that I know very well. And the finance industry is always faced with this challenge of disaster recovery, migration, application migration, and because they're holding people's money, and if banks go down, especially not just disaster, but cyber attacks. And so banks are very, very worried about being able to quickly recover, because if they don't, they could be out of business, because they could have a run on their... So we are working with a bank in Japan, a very large bank, multinational bank as well. And so maybe you can explain what we're working with on that example.
Yeah, good. Okay, so very different industries that like the finance and the banking. So that, as Vito mentioned, that they have the business problem about the such disaster recovery or the keeping or their infrastructure to continuously serving to their clients, or they're keeping the data to the latest version of that. So that the mean recovery time of the, from the such accidental IT failure or the disaster is very, very important. So that nowadays that they have this recovery site in the far from the main site. Well, for example, in Japan, their main site in the Tokyo and the recovery site in the Osaka. The distance about 500 kilometers. And when the accidentally or the disaster, the Tokyo side will be down, that it's immediately shift to the Osaka side, the recovery side, to for the business continuity for them and also their clients. However, there is a lot of data and updating continuously. So that currently the mean time to recovery would be the hours or the tens of minutes. And so that if once the big earthquake hit, such the tens of the minutes of the data will be lost. It's a very, very important issue. of course, not only the banking, but also the us, the client of that. So that they would like to utilizing the IOWN technology, the IOWN all Photonics network, to connecting the main side and recovery side each other, and transmitting data real time. So that their willingness is the 0 time of the mean recovery time. It is very important.
Right.
And also that they would like to mention about the migration of the VM, virtual machines. So if the migration of the virtual machines from the main side to the recovery side, so short time. Once we acquire or predict the early stage of the big earthquake, after we get the damage, we can complete the moving the real-time migration of the virtual machines to the recovery side. Yeah, there are no time of the mean time to recovery.
Right. And again, that's for the banks, that's important that they stay open and keep their doors open.
Yeah.
And in fact, this use case has got a name of, what did we call it? The financial services infrastructure.
Yeah.
Because again, banks have always needed this disaster recovery, immediate disaster recovery. And I can see how this would become kind of a standard in the banking industry to use an IOWN-based APN to help with disaster recovery, not just for their customers, but also for regulators to protect their customers and to protect the whole nation, right?
Yeah, nation.
Banks start to fail. We have big problems, and there's always talk about cyber attacks, and we know that's coming someday.
Of course.
So that's a great example where I think the banks, once we prove out this case, will be an excellent opportunity to further enhance their disaster recovery and compliance issues. Okay, so that's two very different industries. Let's jump to a completely different one again.
Yeah.
The media industry. And so this one is also, it's actually with a partner who's one of the initial founders of the Global Forum, which is Sony. And the idea here is around remote media production, which today is a very cost-heavy, skill-heavy, on-site type of approach. And again, you'll see the same concept of high speed, low latency, no jitter capabilities solves a business problem.
Yeah.
So maybe you can discuss that.
Yeah, thank you. Okay, yes, similar to the other use case examples, the intention is that the lack of the skilled people. And for example, in the media, they have to go to each stadium, or like in the US, the baseball stadium, so that there are several games at the same time, so that they have to secure the skilled people to each stadium for their seeing the video games and collecting the data of the scenery and product the real program of the TVs, and after that to send it to the broadcast.
Right.
But very costly, and also that it is difficult for them to secure the skilled people in the same time. And because not just the time of the game, but also that preparing such production, and after the game that they have to summarize the game or something. Yeah, so that they have to secure the over one day, of the skilled people.
Right.
That once they can provide such the remote production, the production side is a remote, not the on-site. One skilled people can handle the several games, baseball games in this several different stadiums at once.
Right.
They are very, very important to the securing the skilled people.
And so skilled people is one challenge, but also if when there's an event, they have these truckloads of equipment that show up, which is very expensive, and you have to have them there on site. And so this concept then of not concept, but this use case is doing remote media production, but also remote equipment management.
Yes.
So the idea being that once you're there and you're doing the remote management from a skilled person, that site needs to still connect to the broadcast network because we're not broadcasting from there, but you're saving both people time, but also equipment.
Equipment as well.
So that's called, we call that the remote media production, but there's also the network, the shared network, and also the production equipment shared network.
Shared equipment as well,
So again, this is a completely different industry where we're trying to bring more live experiences to people who maybe we wouldn't have sent broadcast quality, because this is broadcast quality type of coverage to these events. And on the other side of this, of course, is going to be our interactive live experiences, right? So it's not only the capturing of the data of the event, but also ultimately using it to do some interactive sports or interactive gaming, those kinds of things. So we're working on both halves of those problems, but the first one with Sony is very real. So, and is that, you're testing that in Japan right now?
Of course, that we are trying to make a POC in Japan that with Sony, and also that for the esports.
Right.
That we NTT have our supporting the esports players, or for the supporting the remote esports. That in this case, the equal conditions is very important for the delay.
Right.
If the time delay is very, very precise.
Yes.
For that, might be I calculate or asking them that they can recognize only 16 millisecond difference.
Right.
Oh, unbelievable.
Otherwise, there's a disadvantage.
And
so if you're going to have a true competitive esports, people know esports, today you have to do it in one place to keep the consistency. This allows esports to happen over the cloud.
Cloud,
using,
remotely, but equal conditions.
Right, equal conditions. Again, back to jitter.
Yes, of course.
Jitter is very important as well. And actually, maybe with, I know we don't have a lot, we knew we were going to run out of time, didn't we? Okay, so I'll have to go to the next one because I wanted to talk about the symphony. But anyway, let's talk about, actually this one is my kind of favorite because it's topical and it makes a lot of sense. And it's around Gen AI training. And we heard this morning, and regularly we hear about the challenge we have with AI consuming so much power and so much electricity. So we need to start looking for ways to help solve that problem while not holding AI back. And we have, in this case, announced it publicly, a group with NVIDIA, Red Hat, and NTT. And we call it the Gen AI Remote GPU Processing. So please, give us your thoughts on that.
There are a lot of the issues. There are very broad interesting from the broad industries to the Gen AI. And however, the GPU is very expensive and power consuming. So that it is difficult for each industry, the enterprises have their own GPUs, the GPU pools. So that once that such a GPU would be provided through the other services, the cloud services, that are very easy to utilize each industry, the companies for that. So that however, the connecting the data, training data and the GPU is a very, very precise or whatever important so for the low latency. So that once that we can connect the on-premise data and the GPU cloud via IOWN APN, that we can provide it as one GPU server. So that for the enterprises, it's easy to use.
And it looks what's fascinating to me about this is that you're able to keep the data in one place, secure in that data center, but do the GPU processing in a high-performance GPU specialized green data center, maybe closer to renewables. So now you're offloading that high intense compute to a more sustainable data center. But not only are you contributing to sustainability, but it's also, today there is some examples of using WAN and using cache and replication, but it's slower and it's subject to errors, whereas this will be cleaner data transmission and also will take less time. So the training of LLMs, as Aragani-san was saying, is going to become an industry in itself, where we actually will probably each have our own trained LLM. It's not just an industry, but even at the individual level. So this concept of GPU supercomputing in one place and data in another is another breakthrough idea that I think the IOWN APN can really enable. Yeah. So that's very exciting, and again, it's working with the top tier companies, NVIDIA and Red Hat and NTT, and I also wanted to mention, in case people forgot, Red Hat is owned by IBM, so that's a big partner of ours as well, and that's all good. So, so we're running out of time. We did have one more thing we wanted to cover, but we kind of talked about this data center connectivity and how we can connect two data centers with low latency and low jitter. You want to take a minute on that? And then we're going to go a minute over, so I'm sorry. Just let's do that.
Okay, thank you. So that we announced yesterday or today that we at NTT is the world's third biggest data center operators. So that they are connecting to our data center each other, that we can provide such that the GP cloud or other issues in the diversity. So that now, as you know, the lack of the data center floor is a very important issue, especially in the metropolitan area in the big countries like the US or the UK, also in Japan. So that if we can utilize the suburban areas data center as similar to the utilization of the effectiveness in the metropolitan area data centers, it is very easy to ask for providing data center side, and also that our client are utilizing the data center side. So that they're connecting the data center with the low latency, the low jitter, and important. And of course that we would like to reduce the impact of the carbon. So the carbon neutrality is very important. So for that purpose, the sustainable energy, utilizing sustainable energy is very important for the contribution to that. As you know, we can utilize sustainable energy more in the suburban area. So that if we can put the more data centers in the suburban area, we can utilize more sustainable energy. That is also very important.
The suburbs might have something to say about it, but we'll deal with that later because they're also worried about moving data centers, but they'll be closer to renewables. All right, so with that, maybe we can put up a screen. I want to close with a little plug for the IOWN Global Forum. The next IOWN Global Forum is actually in Vancouver, Canada, my home country, and it's the week of April 23rd and 4th. And this is the first time the IOWN Global Forum is inviting the public to join us, both online and in person. So we call it the IOWN Global Forum Futures. So please, if you have a chance, look us up and connect online, or come and join us in Vancouver. It's a beautiful city and a beautiful country. So with that, Aragani-san, thank you very much.
Thank you.
I appreciate it.
Thank you.
Thank you very much. Thank you, everyone.
Thank you.
Thank you.